Greetings everyone. Let's explore the grand scale of time through the lens of geology, where millions of years are just the beginning. Time. Time is the measure of non-stop, consistent change in our surroundings, usually from a specific viewpoint. It is essential for sequencing events and understanding the rates at which geological processes occur. Geology. Geology is the study of the earth, its materials, structure, processes, and history. It provides framework for understanding Earth's history, including the formation of continents, oceans, and mountain ranges. Dating techniques. These are the methods used to determine the age of objects or events. These techniques can be broadly categorized into relative dating and absolute dating. There are two dating methods in geology. These are relative dating and absolute dating. Relative dating involves determining the age of rocks and geological events in relation to each other. Under relative dating, there is a method called stratigraphy. It is the study of layered sedimentary and igneous rocks that reveal the history of the Earth and its life. Principles of stratigraphy and how rocks tell stories. There are three principles of stratigraphy. The first principle is principle of superposition. By applying the principle of superposition, geologists can determine the chronological order of events. Each layer represents a slice of time, with the bottom layers representing earlier periods, and the top layers representing more recent times. Next principle is the principle of original horizontality. When rock layers are tilted, folded, or faulted, it tells a story of tectonic activity and deformation. The principle of original horizontality helps identify these deformations, allowing geologists to understand the forces that have acted on the rocks over time. The last principle is the principle of lateral continuity. As a result, rocks that are otherwise similar but are now separated by a valley or other erosional feature can be assumed to be originally continuous. The principle of lateral continuity allows geologists to correlate rock layers across different regions. If similar rock layers are found in different locations, it suggests that those areas were once part of the same depositional environment. Next method is fossil succession. Based on the observation that different fossils appear in specific rock layers, indicating their relative ages. In 20th century, the advent of radiometric dating allowed scientists to determine the absolute ages of rocks, providing numerical dates for the geologic timeline. This involves measuring the decay of radioactive isotopes in minerals, such as uranium-lead dating and carbon dating. Absolute dating techniques. This involves using radiometric dating methods to determine the numerical age of rocks and minerals in years. Radiometric dating, also known as radioactive dating or radioisotope dating, it works by analyzing the constant rate of decay of radioactive isotopes within a sample. Radioactive decay. When the quantities of the parent and daughter isotopes are equal, one half-life has occurred. If the half-life of an isotope is known, the amount of the parent and daughter isotopes can be measured, and the amount of time since the radioactive decay began can be calculated. Common methods are carbon-14 dating or radiocarbon dating, potassium-argon dating, and uranium-lead dating. The geologic timeline or the geologic timescale. This scale is a fundamental tool for organizing the planet's history into units of time based on geological and biological events. The development of geologic timeline involved contributions from various scientists over centuries. It relied on relative dating methods, which place events in order without assigning specific numerical ages. These methods included law of superposition and fossil succession. The geologic timescale is divided into a hierarchical system of units called aeons, eras, periods, epochs, and ages. Reading the geologic timeline involves understanding its hierarchical structure and the events that define each division. Generally, the timeline is presented with the oldest aeons at the bottom and the most recent at the top. Each division is characterized by specific geological and biological events, such as the appearance of new species, extinction events, climate shifts, and tectonic activity.
Value and use of geologic timeline. It provides a framework for understanding the sequence and timing of major events in Earth's history. It also helps track the evolution of life, showing when different species appeared, evolved, and went extinct. It allows geologists to correlate rock layers and events from different parts of the world, creating global picture of Earth's history.